Britain is building a nuclear power plant in Somerset. When it was approved in 2016, they said it would cost £18 billion and be generating electricity by 2025. It is now 2026. The cost has hit £49 billion. The plant won't produce a single watt until 2030 at the earliest. And they just spent £700 million building an underwater sound system to scare fish away from the cooling pipes. £700 million on fish protection. That's more than the entire construction cost of Wembley Stadium. More than the UK spent building the Olympic Velodrome, the Aquatic Centre and the Olympic Stadium combined, on keeping fish away from a pipe. But here's the thing, the fish aren't even the real story. The real story is how the most powerful country in the history of nuclear energy managed to build the most expensive power station on Earth, and it still doesn't work. To understand how Britain got here, you need to go back to a decision made in 1995, because that's when Britain stopped. Sizewell B in Suffolk was the last nuclear power station completed in the UK. It finished in 1995. After that, nothing. For almost 30 years, Britain, the country that opened the world's first commercial nuclear station at Calder Hall in 1956, simply stopped building reactors. It wasn't because nuclear didn't work. Britain's existing fleet ran for decades. It wasn't because the technology didn't exist. France was building reactors throughout the 1990s and 2000s. It was politics, public opposition after Chernobyl, cheaper gas from the North Sea, governments that didn't want to make a decision that would take longer than their time in office to pay off. So they kicked the can down the road for 30 years. Meanwhile, the existing fleet was aging out. Reactors built in the 1970s and 80s were reaching end of life. Coal plants were shutting down to meet climate targets. Gas prices were bouncing around. Wind farms were expanding but couldn't deliver constant baseload power. The steady, always-on electricity that keeps the grid stable at 3 in the morning when the wind isn't blowing and the sun isn't shining. Britain was heading toward an energy gap. Old plants closing faster than new ones opening, and nobody had a plan. That's when EDF showed up. Électricité de France, a French state-owned energy giant that operates 56 reactors in France and runs every active nuclear station in the UK. They proposed building 2 new reactors at Hinkley Point in Somerset, on the same coastline where 2 previous nuclear stations had already operated. The reactor they chose was the EPR, the European Pressurized Reactor, supposedly the most advanced commercial reactor design in the world, more powerful, more safety systems, more redundancy than anything previously built. Each reactor would generate 1,630 megawatts. 2 of them together would supply 7% of the UK's total electricity, enough to power 6 million homes. The deal was structured to protect the taxpayer, or so they said. EDF would finance and build the plant. China General Nuclear Power Group would take a 33.5% stake, contributing roughly £6 to £7 billion in capital. The British government wouldn't pay for construction directly. Instead, they'd guarantee a fixed electricity price through a contract for difference, a strike price of £92.50 per megawatt hour, adjusted annually for inflation. That price has since risen to £127 per megawatt hour. For context, wholesale electricity in the UK trades at roughly £50 to £80 depending on the day. So British consumers will be paying above market rates for Hinkley's electricity for 35 years. Once both reactors are running, that subsidy will cost consumers over £2 billion every single year. The government bet that energy prices would rise high enough to make the deal look reasonable. 9 years later, that bet hasn't paid off. But the money's only half the disaster. The reactor design is where the story turns genuinely dark. The EPR that EDF chose for Hinkley has been built before, 3 times, and all 3 times it went catastrophically over budget and over schedule. The first EPR was Olkiluoto 3 in Finland. Construction started in 2005, supposed to finish by 2009. It finally connected to the grid in 2023, 14 years late. Original budget, €3 billion. Final cost, over €11 billion. The problems were devastating. Incomplete design at the start of construction, quality control failures, faulty welds, documentation gaps, and contractor coordination problems so severe they triggered multi-billion euro litigation between the Finnish utility and Areva, the French reactor builder. The second EPR was Flamanville 3 in France, EDF's home turf. Started in 2007, supposed to be done by 2012. It finally entered commercial operation in 2024, 12 years late. Budget tripled from 3.3 billion euros to over 13 billion euros. And during construction, something even worse emerged. Investigations revealed that Areva's Le Creusot forge, the factory manufacturing critical nuclear components, had been falsifying quality certificates for decades. Hundreds of parts with questionable documentation had been shipped to nuclear plants across France and potentially to export projects. The French Nuclear Safety Authority flagged that identical flaws might exist in components destined for Hinkley Point C. The third and fourth EPRs were Taishan 1 and 2 in China. These actually went relatively smoothly because China has a massive, experienced nuclear construction workforce and a regulatory environment that moves faster. Taishan 1 became the first operational EPR in the world in 2018. But even there, fuel rod damage was detected in 2021, leading to a temporary shutdown of Taishan 1 for inspection and repairs. So when EDF told Britain that Hinkley Point C would be ready by 2025 for £18 billion, the track record was already clear. This reactor design had never been delivered on time or on budget in any Western country. Not once. Imagine you hired a builder who'd done 2 jobs before yours. Both were over a decade late and 3 times over budget. One was caught using falsified parts, and when you asked about it, they said, "Don't worry, we've learned from those mistakes." Would you hand them £18 billion? Britain did. Construction officially began in December 2018. The first years focused on civil works. Massive concrete pours for the reactor buildings, each with containment walls over a metre thick designed to withstand aircraft impacts, earthquakes and internal pressure events. They brought in Big Carl, the world's largest crane standing taller than most cathedrals, capable of lifting 5,000 tonnes. In December 2020, Big Carl completed its biggest ever lift, hoisting a 575-tonne prefabricated steel ring into place, the first of 3 that form the reinforced cylinder around the reactor. Then COVID hit. Social distancing on a construction site with thousands of workers is nearly impossible. Productivity collapsed. EDF added 15 months to the timeline and £500 million to the budget just for pandemic impacts. But COVID was a convenient excuse for problems that ran much deeper. The real issue was that the EPR design required extensive adaptation to meet British nuclear regulations, which are among the strictest in the world. Every system, every pipe, every cable had to meet standards that often go beyond what France requires. When the generic design assessment was conducted before construction began, it identified 724 unresolved assessment findings. By October 2024, 6 years into construction, 255 of those findings were still open. The design was being finalised while the building was going up around it. This is exactly what went wrong at Olkiluoto and Flamanville. Starting construction before the design is complete. It's the single most reliable predictor of cost overruns and delays in nuclear construction. And despite having 2 failed projects to learn from, they did it again at Hinkley. And then there's the China problem. China General Nuclear Power Group, CGN, was supposed to be a key financial partner, contributing billions and bringing experience from building the Taishan EPRs. But CGN had been blacklisted by the United States Department of Commerce for allegedly attempting to acquire advanced US nuclear technology for military use. Over 100 Chinese engineers were working on Britain's most sensitive nuclear construction site. As costs escalated and EDF poured in more of its own money, CGN's ownership stake was diluted from 33.5% at the start to 23.3% by the end of 2025. EDF now holds 76.7% and is shouldering the financial pain almost entirely alone. And that pain is enormous. EDF has lost money on its UK operations for 6 consecutive years because of Hinkley. They've written down the project by over €14 billion in total. In 2016, before the final investment decision was even made, EDF's own finance director, Thomas Piekema, resigned in protest, arguing that the project posed unacceptable financial risks to the company. He was right. By June 2025, EDF had to secure a £4.5 billion emergency debt financing package from US asset management firm Apollo just to keep the project funded. EDF's British subsidiary was carrying €6.7 billion in debt. Let me walk you through the full cost timeline so you can watch the numbers climb. 2016, £18 billion. That's the deal. That's what was promised. 2017, £19.6 billion. Just 1 year in, 2020, £23 billion. COVID costs added, 2022, £26 billion. More delays. January 2024, £31 to £35 billion in 2015 prices, depending on which scenario plays out. Best case, base case, or worst case. In real 2024 money, that's £41.6 to £47.9 billion. February 2026, £35 billion in 2015 prices, which translates to £48.7 to £49 billion in today's money. Nearly triple the original estimate, and EDF's own statement says further increases cannot be ruled out. The latest delay, from 2029 to 2030, was caused by lower than expected productivity on the electromechanical installation program. This is the phase where you install all the piping, cabling, instrumentation, and system integration that turns a concrete shell into a functioning power plant. It's the most complex phase of nuclear construction. And EDF admitted in February 2026 that they're not installing it fast enough. This single problem added another €2.5 billion to the bill. Civil construction on Unit 1 is now 95% complete. The 245-ton steel dome was lifted onto Unit 2 in July 2025. The second reactor pressure vessel, 13 metres tall, weighing 500 tons, was shipped from Framatome's factory in France in December 2025. These are genuine, massive engineering achievements. 26,000 jobs were supported across Britain during 2025. Over 14,000 people have been trained, including 1,700 apprentices. But none of that changes the numbers. £49 billion, 5 years late, and still not done. Now let's talk about the fish, because this is the detail that made the entire country collectively question everything. Hinkley Point C needs seawater from the Bristol Channel to cool its reactors. The cooling system draws in 132,000 litres per second. That's the equivalent of an Olympic swimming pool every 12 seconds, for 70 years. The intake tunnels run 3.3 kilometres offshore under the seabed, and the intake heads installed on the seafloor are massive structures, the cross-sectional area of 6 double-decker buses. The Severn estuary where this water comes from is one of the most protected marine environments in Britain. A special area of conservation, a special protection area, and a Ramsar wetland site. It supports internationally important populations of migratory fish, Atlantic salmon, Thwaite shad, European eel, lamprey. Without protection, those intake pipes would act as giant vacuum cleaners on the seafloor. EDF's own estimates suggest 2.9 million fish per year would be killed. A Welsh Government report put the number at 182 million per year. The two numbers differ by a factor of 60. But even the lower estimate means nearly 3 million fish killed annually for 7 decades. The original plan had 3 layers of protection. First, specially designed intake heads that slow the water flow so fish can swim away from as close as 2 metres. Second, a fish return system, essentially a conveyor belt that catches fish and sends them back to sea. Third, an acoustic fish deterrent, an underwater speaker system that blasts sound to keep fish away from the intake area. Combined cost, over £700 million for fish protection at a power station. But the acoustic deterrent became a saga that lasted over a decade. The original design used 280 underwater loudspeakers producing noise louder than a jumbo jet. The problem? The Bristol Channel has extreme tides, some of the highest tidal ranges on Earth, fast currents, and almost zero underwater visibility. Divers couldn't safely install or maintain the speakers. The risk of a diver being killed was deemed unacceptable, so EDF proposed scrapping the acoustic deterrent entirely and instead flooding up to 900 acres of farmland along the Severn with saltwater to create new marsh habitat as compensation for the fish they'd kill. Farmers were furious, communities revolted, legal challenges were filed, the plan stalled. Then, in early 2025, a small company in Devon called Fishtech Marine developed a new ultrasonic deterrent. Compact. No divers needed. It uses ultrasound instead of loudspeakers. Trials run by Swansea University showed it was over 90% effective. When it was turned on, only 1 tagged shad came within 30 metres of the intake, compared to 14 with the system off. EDF adopted it as their preferred solution. They paused all saltmarsh creation planning, but the system still hasn't been approved by regulators. The application won't be submitted to the Marine Management Organisation until later in 2026. and independent scientists have raised concerns about whether the fish will simply get used to the sound over time, whether it protects all species, and whether it could affect marine mammals like porpoises and minke whales. £700 million and over 10 years of work to figure out how to stop fish swimming into a pipe, and they're still not finished. Meanwhile, Britain shut down its last coal power station in September 2024. The energy gap that Hinkley was supposed to fill is already here. Gas prices spiked after Russia invaded Ukraine. Electricity bills doubled for millions of households, and the nuclear plant that was supposed to provide clean, reliable baseload power is still years away from generating a single watt. And here's where the story gets truly maddening, because there was an alternative, and it worked. In December 2009, the United Arab Emirates, a country with zero nuclear experience, no regulatory framework and no nuclear workforce, awarded a contract to South Korea's KEPCO to build 4 APR-1400 reactors at Baraka on the Persian Gulf Coast. The contract value was $20.4 billion. Fixed price, 4 reactors. Total capacity, 5,600 megawatts, almost double Hinkley's 3,200 megawatts. Construction of Unit 1 started in July 2012. Unit 2 followed in May 2013. Unit 3 in September 2014. Unit 4 in September 2015. 1 reactor per year, like clockwork. Unit 1 entered commercial operation in April 2021. Unit 2 in March 2022. Unit 3 in February 2023. Unit 4 in September 2024. Each unit was delivered faster than the one before. The operators said Unit 3 was delivered 4 months faster than Unit 2 and 5 months faster than Unit 1. They were learning and improving with every reactor. The total cost came in at roughly $32 billion for all 4 reactors. That's more than the original $20 billion contract. Construction costs rose and there were some delays, but it's still 4 operational nuclear reactors producing 40 terawatt-hours of clean electricity per year, supplying 25% of the UAE's power needs and avoiding 22.4 million tons of CO2 annually. Now compare. Baraka. 4 reactors, $32 billion, all operational. Hinkley Point C. 2 reactors, £49 billion, 0 power, 5 years late and counting. Baraka produces nearly double the electricity for roughly the same inflation-adjusted cost. The UAE, a country that had never built anything nuclear before, went from 0 to 4 operational reactors faster than Britain could build one. The KEPCO consortium was chosen over bids from France's Areva, America's GE Hitachi, and Japan's companies. The reason? Highest capacity factor, lowest construction cost, shortest construction time, and KEPCO won on a fixed-price contract, meaning the construction risk sat with the builder, not the customer. At Hinkley, the construction risk sits with EDF, and EDF has been bleeding money for 6 straight years because of it. Even the Czech Republic looked at the options and chose KEPCO. In June 2025, they signed a contract for 2 APR-1400 reactors at a total cost of $18.6 billion, with electricity priced under €90 per megawatt hour. That's cheaper than Hinkley's £127 per megawatt hour. For a newer contract in a country with less nuclear experience than Britain. So here's the question that should keep every British energy policymaker awake at night. And it's not, was Hinkley a mistake? That debate is over. The money's been spent, the plant is being built, it will eventually generate power. When it does, it'll provide 7% of Britain's electricity for 60 to 80 years. That has value. The real question is what happens next, because Britain is about to do it all over again. Sizewell C in Suffolk. Same EPR design, same EDF involvement. The government has committed £19 billion to the project. EDF says it'll be cheaper because it's a repeat build, applying lessons from Hinkley. But lessons from what exactly? From a reactor design that's been late on every single Western project it's ever been built on. From a company that's lost money for 6 consecutive years. In a country that a government commission report called the most expensive place in the world to build nuclear. Now imagine you're a British taxpayer. You pay your electricity bill every month. Buried in that bill is a contribution toward Hinkley's guaranteed price, £127 per megawatt hour, rising with inflation for 35 years. You're paying above market rates for electricity from a plant that cost 3 times what was promised and arrived 5 years late. And now they want to build another one. Same design, same company, And they're asking you to trust that this time it'll be different. If you were the energy minister, and you could go back to 2016 and make the call again, would you sign the EDF deal for the EPR? Or would you pick up the phone, call Seoul, and ask KEPCO to build 4 reactors for the same money on time with a fixed price contract and a proven track record? One phone call, 2 completely different outcomes. What's the number? Tell me in the comments. Because Sizewell C is coming, and the clock is already ticking. I'll see you in the next one.